A very good morning, my dear students. I hope everybody is doing great. And we have come to the last part of the chapter called System of Particles and Rotatory Motion. Once it is done, then the complete syllabus of your first PUC will be finished. Alright, let's continue the topic called a movement of inertia, my dear children. The movement of inertia. A very important things we are going to learn today. And moment of inertia continuation we are doing in the last class. What we have discussed, I hope you remember, this is what a rod which comes under a continuous mass distribution. So this is the rod of length L and the mass M. The center of mass of the rod lies here, and this is what the end of the rod. If this rod is rotating about this axis of rotation, and the moment of inertia we have got ml square by 3. I hope you remember this. Imagine this is the rod, or you take this is the rod. Imagine this is the rod. If this rod is rotating about this axis of rotation, the moment of inertia of it is ml square by 3. If the same rod is rotating about the axis of rotation which is at the center of mass like this, here the moment of inertia will be, ml square by 12, and this is what we have found by using parallel axis theorem, my dear students. And let me revise the parallel axis theorem for your better understanding. So parallel axis theorem is look at here, is equal to ICM plus MD square. This is the parallel axis theorem, my dear students. I andre moment of inertia about any axis of rotation. That axis of rotation may be here, anywhere, which is equal to the sum of moment of inertia of that particular object about the center of mass axis plus mass of the rod into d square. What is d here? So d is the distance between these two parallel axes. ಇಷ್ಟು ಡೀಟೇಲ್ಡ್ ಆಗಿ ನಿಮಗೆ ಎಲ್ಲಿ ಸಿಗಲ್ಲ about the moment of inertia concept. If you really understand these cases what we are doing right now, next cases will be so easy for you, and there are so many formulas to be recollected by you. I can directly give you a formula of this or formula of this, but better the derivation also I have done it. There are some formulas which you must remember. See them later. Focus here. It's about parallel axis theorem, my dear children. And here we must know another topic called radius of gyration, which is denoted with a symbol K, capital K. You know what is meant by radius of gyration? Radius of gyration andre, it's so simple. Let's take this is the rigid body here, and this is what the axis of rotation, and this rigid body is rotating about this axis of rotation, and this rigid body will have the center of mass, right? So imagine this is the center of mass point. From the axis of rotation, the perpendicular distance to the center of mass point, this is called K, radius of gyration. See how simple it is. Radius of gyration is the distance. It is a distance. So it's a unit of distance. So radius of gyration, so it is SI unit is distance. It's a meter. No confusions. Distance from where to where? From axis of rotation to the center of mass of the rigid body, which is rotating about this particular axis of rotation. Now, the point is that there is a relation between, so this radius of gyration and moment of inertia. What is the relation here? So, I is equal to, observe carefully, I'm just writing here, I is equal to mk square and k is equal to root I by m. So, this is the very important 5 stars akolve. Ast importance is this there for this expression. What's the radius of gyration expression? Root I by m. So there is a radius of gyration for this axis of rotation. There is a radius of gyration for this axis of rotation. Understand? So for example, E case tagolri here. So if moment of inertia of the rod about an axis of rotation which is passing through the end of the rod. So I is equal to ml square by 3 ಅಂತ ನಮಗೆ ಸಿಕ್ತು. ಈ ಕೇಸಲ್ಲಿ radius of gyration ಎಷ್ಟು ಅಂತ ಕೇಳ್ತಾರೆ. So what's the radius of gyration in that case? So in this case radius of gyration k is root I by m and this root is ml square by 3 divided by m. M cancel, root l square andre l by root 3. Observe carefully. The radius of gyration in that case we have got L by root 3. In the same way, you get the radius of gyration if you know moment of inertia. Any body. This is an example. We have done it for a rod. Okay, we have done it for the rod. This can be applied, the same formula. It can be applied to a ring, to a disc, to a square plate. Understand? And it can also be applied to a cylinder, to a sphere, hollow sphere, solid sphere, hollow cylinder, solid cylinder, anything. Alright? Now the point is, we are talking about moment of inertia of a body which is having a continuous mass distribution. So right now, you know what we are going to learn? Moment of inertia of a ring, my dear students. Moment of inertia of the ring we are going to discuss, right? So about which axis of rotation? I told you, right? Work done, anta simply you should not say. Work done by what force? That you must mention. Atara. Moment of inertia anta simply now discuss ಮಾಡಬಾರದು. Moment of inertia of a body about what axis of rotation? That is important. Okay. Moment of inertia of the ring about an axis, observe, passing through center of mass which is perpendicular to the plane. Observe. Perpendicular to the plane. See, I have a look at here. This is the ring. Observe. I hope it's visible to everybody. It's a ring. So this is what, look at the situation. Yes, this is what the axis of rotation. Look at here. This is the axis of rotation. About this axis of rotation, the ring can rotate. Yes or no? Yes or no, my dear students? The ring can rotate about this axis of rotation. So you just observe carefully. Look at here, and this is the ring which can be rotated about this axis of rotation. ಈ ಕೇಸಲ್ಲಿ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಆಫ್ ದ ರಿಂಗ್ ಏನು ಅಂತ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ಐ ಹೋಪ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಸಿಚುವೇಶನ್. ಸೊ ಲೆಟ್ಸ್ ಮೂವ್ ಆನ್. See, moment of inertia of the ring about an axis passing through the center of mass. Yes, center of mass of the ring. Center of mass of the ring. Yes, this is the center of mass. Now my axis of rotation is passing through center of mass. Perpendicular to the plane alva. Idu ring plane. Perpendicular to the plane. Nodri. Understand? About this axis of rotation, moment of inertia yenu. Look at the interesting part. Whatever it may be, this ring is also a continuous mass distribution. It's not a point mass. Look at here. There is a small dx can be drawn. Have a look at it. So there is a small dx here. There is another dx, another dx, another dx, another dx, another dx, another dx. So from here to here, throughout the circumference continuously the mass is distributed. ಹಾಗಾಗಿ ಈ ಸಬ್ಸ್ಟೆನ್ಸ್ ಗೆ ನಾವೇನ್ ಅನ್ಬೋದು ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ಎ ಕಂಟಿನ್ಯೂಸ್ ಮಾಸ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅಂತ ತಗೋಬಹುದು. ಓಕೆ, ಆಲ್ ರೈಟ್. Now look at here, whatever it may be the situation, I have told you already, moment of inertia in the continuous mass distribution formula idu I is equal to integral x square dm. All right, and this is the center. Okay, illinda at a distance x, a small length element dx and small mass element dm is considered. Idu dx anta and its mass dm. Total mass of the ring m and total length, its circumference, which is 2 pi r if the radius r andre, right, for this ring. So if the radius is r, total length of this is 2 pi r and total mass is m. I am writing the same. Total mass capital M andre its length is 2 pi r and small mass dm andre its length is dx. So from here ಏನು ಸಿಗುತ್ತೆ ನಿಮಗೆ? From here, so dm ಎಷ್ಟು ಅಂತ ಬರುತ್ತೆ ನಿಮಗೆ? ಏನಂದಮ್ಮ? Capital M by 2 pi r into dx ಅಂತ ಬರುತ್ತೆ. So ಇದನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬಹುದು ತಾನೆ? Yes, 100%. I is equal to integral x square into dm. dm ಅಂದ್ರೆ capital M by 2 pi r into dx. Carefully observe ಮಾಡಿ my dear students. So what is this x? Can I say this x is equal to r? Students, yes or no? Write it in WhatsApp immediately. Can I say this x is equal to r? Definitely. So now this I is equal to integral r square into m by 2 pi r into dx. One r cancel ಆಗುತ್ತೆ ಇಲ್ಲಿ. And so we'll just write it outside, whatever it is there. So m into r by 2 pi integral dx amma. Integral dx. I have just told you, ಇದು dx amma. ಇನ್ನೊಂದು dx ಅಂದ್ರೆ ಇದು, 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 ಇನ್ನೊಂದು dx ಅಂದ್ರೆ ಇದು. So integration of all these small length elements will gives you circumference ತಾನೆ, mr by 2 pi integral dx ಅಂದ್ರೆ it's 2 pi r. Will you agree with this, my dear students? Integral dx andre summation of all these small elements. So you have got like this. So illi 2 pi cancel agutte and you have I is equal to mr square, my dear students. I is equal to what? Mr square. A moment of inertia of this ring about an axis passing through the center of mass which is perpendicular to the plane, my dear students. So moment of inertia of this ring, observe, moment of inertia of this ring about an axis passing through center of mass and perpendicular to the ring. E case alli it's mr square. What is this in this case? It's mr square. Observe carefully, and we are going to move into the deeper levels of the concept of this moment of inertia of the ring right now, right? So ಹಾಗಾಗಿ ಚೆನ್ನಾಗಿ ನೋಡ್ಕೊಳ್ಳ್ರಿ. And moment of inertia of this ring about the center of mass ನಮಗೆ ಸಿಕ್ತು, ಇದು mr square ಅಂತ. And moment of inertia find out ಮಾಡಿದ್ರೆ immediately ಈ moment of inertia ಟಾಪಿಕ್ ಅಲ್ಲಿ ನಾವೇನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ immediately radius of gyration find out ಮಾಡ್ರಿ. Radius of gyration ಫಾರ್ಮುಲಾ ಏನಮ್ಮ? It's root I by m ತಾನೆ. So will I use the same? So k is equal to root I andre emr square divided by m. m cancel ಆದ್ರೆ so k is equal to r ಅಂತ ಬರುತ್ತೆ. K is equal to r. K is equal to r. So from here I can also write it as k square by r square is equal to 1. ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಇದು ನೆನಪಿಟ್ಟುಕೊಳ್ಳಿ. Again I am telling you, this will be useful in the further concepts. K is equal to r. From this formula, k is equal to root I by m. We have got k is equal to r. ಈಗ both sides you just apply square. K square by R square 1 anta barutte. For the ring about this axis of rotation, K square by R square value is 2, 1. Okay? Clear? Now, what we are going to do, we are going to continue the concept of ring itself. Continue the concept of ring itself. That's called the in-depth analysis of the ring concept. In-depth analysis of the ring concept. So this is what the moment of inertia of the ring about an axis passing through center of mass perpendicular to the plane. Now, moment of inertia of the ring only, but about an axis passing through center of mass only in the plane of the ring. Look at the difference. Here also, it's a ring. The axis of rotation is passing through center of mass, but it is passing through the center of mass in the plane of the ring. This is the plane of the ring. In the plane of the ring and the right? So look at here. Look at here, my dear children. Look at here. I have made it for you. See this, everybody. Now the ring is rotating like this. Look at here. Gone. Now the ring is rotating like this. See. I hope it is visible to everybody. The ring is rotating like this. The previous rotation is different and this is different. The previous rotation is different and this is different. Observe carefully. Observe carefully. Understand? Understand? So now this is also, the ring is passing through the center. The axis of rotation is passing through center of mass only. The axis of rotation passing through center of mass only. But the axis of rotation is in the plane. The axis of rotation is in the plane. I hope you are getting the point. Okay. So, in case how to find the moment of inertia, and remember this. And there is a concept called a perpendicular axis theorem, my dear students. What is that? Perpendicular axis theorem. You know what is this perpendicular axis theorem? What is this perpendicular axis theorem, It's a Ix plus Iy is equal to Iz. So that is a perpendicular axis theorem. So simple. So simple. Ix plus Iy is equal to Iz. Look at here. This is the plane of the ring. Observe. Plane of the ring. This is the plane. We'll have on x-axis. Look at here. This is x-axis of the ring and this is y-axis of the ring. Observe, my dear students. Either x-axis of the ring and this is y-axis of the ring. So for example, I will tell you by keeping here, my dear students. Observe carefully. In the ring x plane, this ring will have x-axis like this. This ring will have y-axis like this. Yes, like this. This ring will also have the z-axis, right? That is z-axis. Observe. This is the ring. This is the plane of the ring. So this is the x-axis of the ring. About this x-axis the ring can rotate. How? About x-axis the ring will rotate. Like this, Tane. Fine. This is the y-axis of the ring. About y-axis how it rotates? Like this. Right? Now, about z-axis, how it rotates, my dear student. This is a z, right? So this is the z. About z-axis, how it rotates. This is how it rotates. I hope the complete picture you have got it. I hope the complete picture you have got it. So moment of inertia about x-axis of the ring plus moment of inertia about y-axis of the ring is equal to moment of inertia about z-axis of the ring. This is the ring I have. X-axis is there, y-axis is there and z-axis is there. right? You know what is this value? E value mr square anta ನಿಮಗೆ ಗೊತ್ತು. Yes or no? E value mr square anta ನಿಮಗೆ ಗೊತ್ತು. Now observe the situation. So according to perpendicular axis theorem, my dear students, so Ix plus Iy is equal to ಇದು Iz, moment of inertia about z axis of the ring. So that's called perpendicular to the plane of the ring. ಅದು mr square ಅಂತ ನಾವು ಆಲ್ರೆಡಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ವಿ, ಇಲ್ಲಿ ನೋಡ್ರಿ. And one more interesting thing. ಇದೇನಮ್ಮ along x axis ತಾನೆ, x axis ಅಂದ್ರೆ ಇದು. So now the axis of rotation is passing through diameter. Will you agree with that? The axis of rotation is passing through diameter. About the diameter, the ring is rotating. See, about the diameter, the ring is rotating like this. About the diameter. Fine. That's Ix. Iy ಏನು? This is y axis. This is also axis passing through, even y axis also, the axis is passing through diameter ತಾನೆ. See this. The axis is passing through diameter and the ring is rotating about the diametric axis, and along x-axis also the same. The ring is rotating about the diameter. ಅಂದ್ರೆ so Ix agli or Iy agli, both are the moment of inertia of the ring about the diameter only. See here, this is x-axis. See here, this is y-axis. Same. About the diameter only, moment of inertia of the ring. So, ನಾನೇನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ Ix is equal to Iy ಅಂತ I can write. ಯಾಕೆ? Both are moment of inertia of the ring about diametric axis ಅಂತ mean. So now this in substitute ಮಾಡಿ. So Ix plus Ix, 2Ix is equal to mr square. So Ix is equal to mr square by 2. My dear students, moment of inertia of a ring about an axis passing through center of mass in the plane of the ring. Passing through center of mass in the plane of the ring andre about diameter. This is the center of mass point. See, now Iy, let's take. See, this is the axis is passing through center of mass tane. This is also axis passing through center of mass. This is also axis passing through center of mass. Understand? Clear? That is what this one. So moment of inertia of the ring about an axis passing through center of mass in the plane of the ring. Understand? So what is the answer we have got? Mr square by 2. In the same way, Iy is also mr square by 2 tane. Iy is also mr square by 2. Moment of inertia of the ring we have got mr square. Moment of inertia of the ring we have got mr square by 2. ಯಾವಾಗ mr square by 2, ಯಾವಾಗ mr square ಅಂತ ನಿಮಗೆ ಗೊತ್ತಾಗಬೇಕು. Actually ಈ derivations ಯಾರು ಮಾಡಲ್ಲ. Most of the students will by heart this. But now ಹಂಗಲ್ಲ, right? So ನಮ್ಮ students are different from others. ಹಾಗಾಗಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. Alright, now continue. One more. So ಈ one more ಏನಂದ್ರೆ moment of inertia of the ring only about an axis passing through, carefully see, passing through a tangent, observe, perpendicular to the plane. ಇದಾದ್ಮೇಲೆ ಇನ್ನೊಂದು ಕೇಸ್ ಇರುತ್ತೆ. So many cases. perpendicular to the plane, tangent. Look at here. This is the situation. See. You understand? Everybody. This is the ring. Now the ring is rotating about this axis of rotation also. The ring can also rotate about this axis of rotation. Observe everybody. See. The ring can also rotate about this axis of rotation. ಈ ಕೇಸಲ್ಲಿ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಆಫ್ ದ ರಿಂಗ್ ಎಷ್ಟು ಅಂತ ಕ್ವಶನ್, ರೈಟ್? ಎಷ್ಟಾಗುತ್ತೆ ಇಲ್ಲಿ? ಲೆಟ್ಸ್ ಲುಕ್ ಎಟ್ ದ ಸಿಚುವೇಶನ್. ವಿ ನೋ ದಿ ಕಾನ್ಸೆಪ್ಟ್ ಕಾಲ್ಡ್ ಪ್ಯಾರಲಲ್ ಆಕ್ಸಿಸ್ ಥಿಯರಮ್. ಅಕಾರ್ಡಿಂಗ್ ಟು ಪ್ಯಾರಲಲ್ ಆಕ್ಸಿಸ್ ಥಿಯರಮ್ ಏನಮ್ಮ? I is equal to ICM plus MD square. ಇದು ಪ್ಯಾರಲಲ್ ಆಕ್ಸಿಸ್ ಥಿಯರಮ್. I ಅಂದ್ರೆ ಏನು? ಈ I ಬೇಕು ನಮಗೆ, ಇದು ಈ I ಬೇಕು. ಓಕೆ, I which is equal to ICM ಏನಮ್ಮ? parallel axis. So this is one axis and ಈ ತರ ಇನ್ನೊಂದು axis ಇದೆ ತಾನೇ ಇಲ್ಲಿ ನೋಡ್ರಿ. ಇದೊಂದು axis ಮತ್ತೆ ನಮ್ದು ಇದೊಂದು axis. ಎರಡು parallel axis ತಾನೇ ನೋಡ್ರಿ. Two are parallel axis. So this axis we need. And this is already know. This already you know. What is this value? Is it mr square? Moment of inertia of this ring about this axis is mr square. So about center of mass it is mr square plus md square. md andre I told you already distance between two parallel axes. So let me write once again. So d andre distance between two parallel axis, right? So this is r square. Distance between two parallel axes enama nodri. You only tell me what's the distance between two parallel axes. Is it r radius of the ring? Yes, see here. Is it the radius of the ring? Everybody is in all the directions. I'm just showing. Everybody look at here. What's the distance between two parallel axes? So that's a r. So mr square plus mr square, so that's 2mr square. Okay, so moment of inertia ee case alli 2mr square. How many moment of inertia values we have got? mr square by 2 2mr square. ಇನ್ನೊಂದು ಸಿಗುತ್ತೆ ನೋಡ್ರಿ ಇನ್ನೊಂದು moment of inertia of a ring about an axis passing through a tangent observe parallel to the plane of the ring. Students, parallel to the plane of the ring andre ಇದು plane of the ring, ಇದು tangent parallel to the plane of the ring. Previous one tangent perpendicular to the plane of the ring. ಈಗ tangent parallel to the plane of the ring. Okay, see about this also the ring can rotate. Observe. ಅಂದ್ರೆ we'll play, right? The children will play. See this. ಇದಲ್ಲ ಈ ತರ ನೋಡಿ, ಚಿಲ್ಡ್ರನ್ ವಿಲ್ ಪ್ಲೇ ಜನರಲಿ, ರೈಟ್? ಇದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಬರ್ತಾ ಇದೆ ಈ ತರ ನೋಡಿ, ರೈಟ್? ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ಕ್ಲಿಯರ್? ಸಿ ಹೌ ಇಟ್ ಈಸ್ rotating. Everybody, yes, like this ma. About a tangent parallel to the plane. About the tangent perpendicular to the plane ಅಂದ್ರೆ ಇದು ನೋಡಿ, ಇದು ನಮ್ಮ ಕೇಸ್ ಏನೀಗ ಇದು, ರೈಟ್? ಸೊ ಈ ಕೇಸಲ್ಲಿ ನೀವು ಚೆನ್ನಾಗಿ ನೋಡಿದ್ರೆ ಇಲ್ಲಿ ಪ್ಯಾರಲ್ ಆಕ್ಸಿಸ್ ಥಿಯರಮ್ ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ ನೋಡ್ರಿ. ಇದೊಂದು ಟ್ಯಾಂಜೆಂಟ್, ಈ ಸ್ಟಿಕ್ಕರ್ ಇದೆ ನೋಡ್ರಿ ಮಿಡ್ ಒನ್, ಅದು ಪ್ಯಾರಲ್ ಆಕ್ಸಿಸ್ ಅಂತ ತಗೋಬೇಕು ಅಷ್ಟೇ. ಇದೇನು ಪ್ಯಾರಲ್ ಆಕ್ಸಿಸ್ ಅಂದ್ರೆ ಥ್ರೂ ಡಯಾಮೀಟರ್ ತಾನೆ, ರೈಟ್? ದ ಸೇಮ್ ಥಿಂಗ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೂ ದಟ್. we need ಇದು this we need, right? This is we need about an axis passing through a tangent parallel to the plane. Yes, ಇದು ಬೇಕು ನಮಗೆ. ಇದು ಬೇಕಂದ್ರೆ ಇದು ಆಲ್ರೆಡಿ ಬಂತು, ಏನು moment of inertia passing through center of mass. Okay, passing through center of mass only in the plane ತಾನೆ, ಅದೇ diameter. So about an axis passing through center of mass in the plane, so that is what the diameter. Through the diameter, what is that? mr square by 2. So that is mr square by 2 plus m into d square andre r square. This is also the distance, perpendicular distance between these two parallel axes. Enamma illinda illige, what is that? Is it radius? Yes. So this is 3 mr square by 2. So this is 3 mr square by 2. ಎಷ್ಟು ಫಾರ್ಮುಲಾಸ್ ಇದಾವೆ ನೋಡ್ರಿ. ಹಾಗಾಗಿ ಅಷ್ಟು ಇಂಪಾರ್ಟೆನ್ಸ್ is there. ಒಂದು ರಿಂಗ್ ಕೇಸಲ್ಲಿ ಇಷ್ಟೊಂದು ಇದಾವೆ. So this is called the deeper analysis of the concept, one by one, case by case. Okay. So I is equal to mr square by 2. I is equal to mr square. I is equal to 3 mr square by 2. ಇದು mr square by 2. Either 2mr square. In every case you can find radius of gyration. Once again, for your better understanding, radius of gyration is equal to root I by m. In case I am finding 3 mr square by 2 divided by m. M cancel, so root 3 by 2 into r. Okay, what is that? K is equal to root 3 by 2 into r. That's the radius of gyration, right? So ee tara we will be learning for different objects. So you can take a square plate, for example. So this is what the book I have. Observe here, this is a book I have, and here there is a moment of inertia about an axis passing through center of mass like this. And this book can also be rotated like this. And this book can also be rotated like this. This book can also be rotated like this. Observe carefully. This book can also be rotated like this. This book can also be rotated like this. So about each and every axis of rotation, the moment of inertia is different. Just a minute. Look at this ball. Everybody, look at the ball. And in case alli careful agi observe madidre, so this ball can be rotated like this. See, about this. The axis of rotation is passing through center of mass. Understand? This is a solid ball, solid sphere. You can say solid sphere. And in the same way, yes, see here, this is the axis of rotation on Colby, for example. This is the axis of rotation, tangent, passing through the tangent. So now the ball can rotate like this about this axis of rotation also. In case alli moment of inertia of this solid sphere is different. Understand? Same way for hollow sphere it's different. Same way for cylindrical object it's different. About different axis of rotation, moment of inertia will be different. And I'm going to share a PDF file with you. Write those points neatly in your notes. Let's have a look at this, my dear students. Of course, I'll send a PDF to you, but still, these are the complete concepts which are useful for our numericals up to the advanced level. Moment of inertia of some regular bodies. Uniform rod we have discussed already. You just have a look at it. ml square by 3, ml square by 12. When ml square by 3? When the rod is rotating about an axis passing at the ends through the center of mass, ml square by 12. And ring, there are 4 cases. mr square by 2, 3mr square by 2, 2mr square by 2. Sometimes the ratio will be asked like this. What is the ratio of this and this, they will ask, right? So what is that? So 3mr square by 2 divided by 2mr square. mr square cancel. So what is the ratio we have got? So 3 by 4 ಬರುತ್ತೆ. ಆ ತರ questions ಕೇಳ್ತಾರೆ. Sometimes the ratio can be asked between ring and the disc. Ring ಅಲ್ಲಿ axis of rotation is passing through center of mass perpendicular to the plane is mr square. In case of disc, the axis of rotation is passing through the center of mass perpendicular to the plane mr square by 2 ಅಂದ್ರೆ. This also we can derive, but not required. The detailed concept of derivation ನಾವು ring concept ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. And in case of disc, you got mr square by 2. In case of ring, for the same axis of rotation, it's mr square. Like that ratio also can be asked. Next, solid sphere. And most of the cases in the NEET, JEE, CET exam, the question was asked based on sphere. That may be solid sphere or hollow sphere. In most of the cases, solid sphere question was there. Because you can consider Earth as a solid sphere here. Agagi, moment of inertia of this solid sphere about an axis passing through center of mass 2 by 5 mr square. If it is hollow sphere, that's 2 by 3 mr square. About a tangent, 7 by 5 mr square. About a tangent in case of hollow sphere, 5 by 3 mr square. Alright. Now, square plate, I have discussed already. When the axis of rotation is passing through center of mass ml square by 6. Solid cylinder, moment of inertia about an axis passing through center of mass mr square by 2. Hollow cylinder, mr square. Understand? Clear? So this is how the concepts will be asked. And in the next class we will be discussing mostly the numericals related to this moment of inertia concept and the next topics. Alright? And all the very best and revise everything. Signing off. See you tomorrow.